Hi friends and my dear students. Today we are going to see the important topic of the effect of frequency of incident light on stopping potential. To study the effect of frequency of incident light on stopping potential, the intensity of the incident light is kept constant. Here we want to find the effect of frequency of incident light between the stopping potential so that we are keeping intensity is constant. Intensity is a constant value. So when we are keeping the variation in the frequency of incident rays and the variation in the stopping potential by keeping intensity is a constant, what will happen? That is a very important result we are acquired, and then we draw a graph and we finally give the conclusion. Now, the variation of photocurrent with the collector electrode potential is studied for radiation of different frequencies and graph drawn between these two them. That's a thing that we are going to make in this experiment. But one thing is clear: when keeping constant of the intensity, then if you draw a graph like this is called zero voltage and this is called photocurrent. Photocurrent, I am simply writing IP. Photocurrent, photocurrent, and then collecting electrode. This is anode potential. Simpler, we can say anode potential. Anode potential is nothing but collector potential. That is positive side and this one is the negative side. Now we have to, here we have to change the frequency. That's why we have to consider in the x-axis yes, potential. Here the stopping potential. That's why we are called anode. Anode, it is nothing but collector potential. Okay. Now what actually the setup of experiment, by keeping constant of intensity, you have to consider frequency of nu 1 of the incident ray first. When you are allowing this frequency of nu 1 of light rays or ultraviolet rays, what will be happen? There may be ejection of electron, and there is a current entering to the anode terminals. Then we are getting current. But if you draw a graph, the graph may like this. Here there is a negative voltage. The graph may like this. Why the anode potential are moved in the negative direction? What is the reason for that? In the prior concept we already explained, if the energy of the electron possesses more energy, even though the anode, which will not allow the free electron to enter this terminal, for that we have spend some amount of work to band it. That's why the potential become very less and a negative voltage. If whatever it may be the negative voltage, in case some other powerful electron are tunneling this work and enter to this anode, so that there is a meager amount of current. But in order to avoid completely stop this photocurrent, then we have to spend much more work done. That work done is possible only IP is 0 only at the cutoff voltage. Only at the cutoff voltage. We already seen in the before experiment. Now, at a particular frequency of nu1, what happened here? This is called cutoff voltage, or simply we can say voltage V01. That means nu1 voltage 1, negative voltage. That means if the incident ray frequency of possessing the frequency of nu1, then the voltage, stopping voltage is said to be minus V01. In other words, you can increase the frequency of incident ray like nu2, slightly raised. So if you are increasing the incident ray or ultraviolet rays frequency, what happened here? There may be most energetic particle are emitted. Most energetic particle emitted and move towards the anode, then the stopping potential also increased. That's why we are getting graph like this. The graph like this. I think you may understood. You are increasing the frequency of the incident ray. The stopping potential may be increased. But there is no current increase. That's a very important concept. And this one is called V02. Thirdly, if you are increasing furthermore the frequency value in very much high, then the incident ray energy also very much high, and the emission of the electron is the kinetic energy of the outcoming electron from the cathode terminal is very very high, so that the stopping voltage will rapidly raised like this, minus V03. Then the graph will be like as shown in the figure. Here in this result of this graph between the current and the stopping voltage, what we observed means, if the incident ray frequency is increased, this one is called nu1 and this one is called nu2 and this one is called nu3. Here nu3 is greater, so that minus V03 also lesser. This one is greater, this one is lesser. V3 is greater than nu2 and greater than nu1, but stopping potential increase means the negative value increase. That's why minus V03 is less than minus V02 is less than minus V01. This is the result that we are obtaining from this experiment. From this graph, we conclude that the stopping potential are varied only because of the incident ray frequency are modified and corresponding output emission of the electron energy also increased, so stopping potential will be modified in accordance with the frequency. That's a very important concept. Now, from this experiment we conclude that one famous important conclusion: if the greater frequency of the incident radiation, larger is the corresponding stopping potential. This implies that as the frequency is increased, the photoelectrons are emitted with greater kinetic energy, so that the retarding potential needed to stop the electrons or photoelectrons is also greater. That's a very important concept. This is the conclusion of this experiment. Then we shift over to another part of this explanation with the help of two metals. Now we explain it. What are the relation and what are the results that we are obtaining in the same? If you make an arrangements, frequency of incident radiation that you have to consider in the x-axis, frequency of the incident radiation, frequency of incident radiation, and y-axis, then we have to consider stopping potential. Generally we say V naught or stopping potential. Okay. If suppose you have to consider metal 1 or metal A like this, if any changes in the incident radiation frequency, then corresponding stopping potential also rise linearly if you are increasing linearly in the incident radiation. That means there is a limitation of the frequency. Within this, less than this frequency, there is no emission of electrons, and that frequency is called threshold frequency. Within this, less than this frequency, there is no emission of electron. But above the threshold frequency, when you are increasing the frequency, then stopping potential also increase. If you are increasing linearly the incident radiation energy, the stopping potential also increase linearly for the metal B also. That is a famous important conclusion for this chapter or from this graph itself. That's a very important concept and conclusion. But I want to give a detailed suggestion for this whole question. If any question was asked in the 7.21 or 7.22 or 7.23 or 7.24, it was asked separately in 5 mark question, then you have to first draw the diagram. Then you have to explain the graphical representation and the experimental data. Whatever it may be the topic. 7.21 separately asked, it will be 5 mark. 7.22 or 7.23 or 7.24, whatever it may be, first you have to draw the figure. This is the basic needed for 2 mark. This if you draw the figure, you get it 2 mark. Then remaining you have to write something and graph, and remaining the result and the entire things at only 2 marks. So very important. I hope this entire 7.21, 7.22, 7.23 and 7.24 are very much clear and very much satisfied. If you have any doubt, then you comment me and I will answer for you all your questions. And thank you very much for your attention. And if you are satisfied, subscribe my channel and click the bell. And you want to continuously watch my classes, then click the all bell. Then only you are able to receive all my classes continuously. Then you can enrich your knowledge in physics and score more marks. Thank you, my friends. Thank you.